Hello. In today's video, we are going to be looking at geometric sequences and series. So geometric sequences and series are when basically you're multiplying or dividing by the same number over and over. They call it a ratio. So the ratio between the first two terms or any two terms that are next to each other is going to be constant. So again, you're multiplying or dividing by the same number constantly. So for example, you can tell here in the first example that from 6 to 12, they're multiplying by 2. That's the ratio. The way that it's looked at is 12 over 6 would be the ratio, which is 2. We don't really have to do the ratio when you can tell just by looking at it. If I multiply by 2 again, that would be 24. So this is not geometric because the second ratio is actually 20 over 12, which is 4 goes into that. So it's 5/3. So it's not 2. Okay, so you don't have to go any further and it's not geometric. For the second kind, you might not be able to tell what's going on. They're definitely dividing. From here to here, you can tell that they're dividing by 4. So all you really have to do is check the other ones and see. If you want, you can do a fraction. So you could do 64 over 256. Then you could do 16 over 64. Then you could do 4 over 16 and 1 over 4. And if you reduce all those, they give you 1/4 because they are dividing by 4 as they go along. The common ratio is 1/4. And yes, it's geometric. So when the ratio is a fraction that's smaller than 1, that means that they are dividing. The numbers are getting smaller and smaller and smaller. The next number would be 1/4. The next one would be 1/16, 1/64, 1 over 256. And you can kind of see the pattern. Go ahead and try the next two on your own. You should have already tried these first before you play the video again. So for the next one here, they are multiplying by 6 every single time. And you need to check all the numbers. Just use your calculator and you can check them all. So the answer is yes. And they have a common ratio of 6. Now, when you have fractions, the easiest thing to do when you have fractions is try the top numbers and the bottom numbers. Okay? So at the top, it's being multiplied by 3 and then not by 3. And the bottom multiplied by 2 and then not by 2. So it's already know. But if it was like 1/2, let me just try to make something up, 2, 6, 4, 18ths. Then at the top, they're multiplying by 2. At the bottom, they're multiplying by 3. So the common ratio would be 2/3. And you can kind of see it that way. Okay, you can do the top and bottom separately. This is just like a separate example. Okay. Next, you can do the same thing with these 3 if you'd like. Go ahead and you can probably do them fairly quickly on your calculator and figure that out. This one is yes. The common ratio is 1/3. Okay, which is dividing by 3. That's the ratio when it's a fraction. For this one, they're multiplying by 3, then by 4. So it is a pattern, but it's not geometric. And for this one, they're multiplying by -2, -2, -2, -2. So yes, the common ratio is -2, and it is geometric. All right, writing a rule. So a rule, again, is a formula. And for geometrics, as opposed to arithmetic where we needed A1 and D, okay, so for arithmetic, when they added, we needed A1 and D, common difference. Here we need A1 and we need R, common ratio, okay? So the first term is 5. And the common ratio is what they're multiplying by. So they're multiplying by 3. The rule is a sub n. I know I say an, but it's a sub n. And it's the first term times the common ratio to the n minus 1 power. And there's nothing else that you need to do. So as soon as you have these two values, you just put them into the formula. You don't have to work anything out, and then you're done. For the 8th term, you can plug 8 here, or you can actually just keep multiplying until you get to the 8th term. So if you have 135 in your calculator, then you're just multiplying by 3 to get the 5th, 6th, 7th, and 8th term, and you just keep multiplying by 3 over and over and over again if you wanted to. Or for the 8th term, it's going to be 5 times 3 to the, we're going to take this 8 minus 1 to the 7th power. So you have to do the exponent first, so do 3 to the 7th times 5. So you would get 10,935. Try the second problem and then come back and check it. All right, so A1 is 88. The common ratio, they are dividing by -2. So that means that you have a common ratio of -1/2, not -2. -2 would be if you are multiplying and the numbers were getting bigger. So if you want to do the ratio, and that should be a -11 right here. So sorry if yours isn't. It should be a -11 in that point. Okay, so the formula AN is equal to 88 times -1/2 to the n minus 1 power. And then to find the 8th term, you do -1/2 to the 8 minus 1 to the 7th, which is 88 over 1 times -1 to the 7th and 2 to the 7th. So that's 88 over 128, which is -11/16. That's the 8th term. Now, doing it the other way, so if I have 88, -44, +22, -11, if I multiplied this by a half, -1/2, I should say, then it would be 11 over 2. And then the next term, you just multiply, when you're multiplying by -1/2, you're just multiplying the top by -1, and you're multiplying the bottom by 2. So if I multiply the top by -1, and I multiply the denominator by 2, that gives me that number. If I multiply the numerator by -1, and I multiply the denominator by 2, and then if I multiply the numerator by -1, and multiply the denominator by 2, you can see that that's the 8th term. 1, 2, 3, 4, 5, 6, 7, 8, which is the number we got here. So either way is fine. Next, try these first, pause the video, come back and check your answers. Okay. So they want us to find the rule and then the 10th term. So A1 is 6. They're dividing by 3, so the common ratio is 1/3. So 6 times 1/3 to the n minus 1. And 1/3 does need to be in parentheses. If you want the 10th term, then it's 6 times 1/3 to the 10 minus 1. So that would be 6 over 1 times 1 to the 9th, 3 to the 9th power, which is 19683. And then if you reduce that, your final answer will be 2 over 6561. The denominator is made up of just 3's because it's 3 to the 9th. So you definitely know that you can divide 6 by 3 and that number by 3. Also, you can put it in your calculator to reduce, but since again, the denominator is made up only of 3's, it's 3 times 3 times 3, 9 times. So the only number that goes into the denominator is 3 and any multiple of 3. So the other number that goes into 6 is also 3. For the next problem, the first term is 10. The common ratio, r, is 2. That I'm multiplying by 2. So the rule or the formula is a sub n is equal to 10 times 2 to the n minus 1 power. And then you want the 10th term, so it's going to be 10 times 2 to the 10 minus 1 power, or 9. So that's 10 times some big number, whatever 2 to the 9th is, which is 512. So this is 5,120. Okay, next. Let's go ahead and do example 3. So in example 3, we have to write a rule, and they don't give us everything. So we need A1 and we need R. So they tell us R is 2, okay? So we already know that the rule is going to be some number times 2 to the n minus 1 power, but I don't know what the first term is yet. So in this case, it tells us that the fourth term is 12. 1, 2, 3, 4. And unlike the arithmetic where I just put random dashes, I'm going to actually put all 4 of them. I'm going to count them out, as many as they give me. So the fourth term is 12. And since R is 2, for the geometric ones, instead of doing a formula, it's just easier to write them out and figure out your way back. Since R is 2, that means that from here to here, they're multiplying by 2, multiplying by 2, multiplying by 2. Okay? That means on the way back, they're dividing by 2. So that has to be dividing by 2. So you're basically using the reciprocal on the way back. When they're whole numbers, it's not that big of a deal. So on the way back, you're doing a half. But let's say they were multiplying by 2/3 in this direction. That means they'd be multiplying by 3/2 in the other direction, which is the same thing as dividing. Anyway, so for 6, if we divide that by 2, that's 3. And if we divide that by 2, that's 3/2. That means that the first term is 3/2. Please don't use decimals. Leave it as a fraction. And that's the first term. Try extra example 3. And then I'll stop the video at this point and we'll do a separate one to do the rest of these notes. All right, so I'm going to go ahead and do this one. So A1 and R. So R is 2/3. I didn't even read that, so that's pretty interesting that I mentioned that up here. So let's see, 1, 2, 3, 4, 5. So the fifth term is 32. So in this direction, they're multiplying by 2/3. So in this direction, they're dividing by 2/3. Dividing by 2/3 is the same as multiplying by 3/2. You just flip that over. So I'm going to multiply 32 by 3/2. Multiplying by 3/2 means you multiply by 3 and divide by 2. So 32 divided by 2 times 3 is 48. And then 48 divided by 2 times 3, that's 72. 72 divided by 2 times 3. And 108 divided by 2 times 3 is 162. So this is the first term. That's the second term, third, fourth, and the fifth. And so the first term is 162. So my formula is 162 times 2/3 to the n minus 1 power. And in example 4, we're going to be writing a formula or a rule for a geometric sequence where they give you 2 terms. All right, so we still need the first term and we need the common ratio. Okay. Now, they give us the second term and the fifth term. So immediately from here, I know that R is going to be a number bigger than 1 because the numbers are getting bigger. They're multiplying by something, and you can try to do a guess and check. Guess and check will work fine if it's a whole number. So if it's a whole number, then you'll get the right answer pretty quickly. You can try the number 2, then 3, then 4, then 5, until you get to the right answer. And you can probably hopefully you can tell that this is going to be, a common ratio is going to be negative, because if you're starting at a positive number and this is a negative number, then R has to be negative. That's the only way to get there when you're multiplying. Okay, so without guessing, there is another way of doing it. So we're talking about ratios, and ratios are multiplication, or we're either multiplying or dividing. So we're going to be multiplying by R, multiplying by R, and multiplying by R. That means that's R to the third power. R times R times R. Now, in order to get from 12 to negative 68, you're basically saying 12 times something equals negative 68. So this entire multiplication, if we call this X, if we divide negative 768 by 12, we get negative 64. So that means that R to the third is equal to negative 64. Because it's from here to here, you're multiplying by 64. And so you're trying to figure out what times what is equal to the same thing as multiplying by negative 64. So if you take the cube root here, then you get R is equal to negative 4. And if you try that out, 12 times negative 4 is negative 48. And then negative 48 times negative 4 is, I believe, 192. I'm trying to do that in my head really quick. So 160 and 32. And then if you divide by negative 4, when you come back, that's negative 3, because on the way there, we're multiplying by negative 4. So it means on the way back, you're dividing by negative 4. So the first term is negative 3 in this case, and R is negative 4. Now, sometimes one will be positive and one will be negative. Like if this was the first term, then your first term would be positive and R can still be negative. They're not dependent on each other as far as their signs go. Okay, so the rule or the formula will then be A sub n is equal to the first term times a common ratio to the n minus 1 power. All right, try the extra example 4, and if you want, actually try all 3 of these and come back and check your answers afterwards. After you pause. All right, so again, we need A1 and we need R. Skip over here a little bit more. Give myself some room. We have all the way to the 6th term. 1, 2, 3, 4, 6. The third term is 20, and this is negative 160. So again, it's going to be a negative value. And again, we're multiplying R 1, 2, 3 times, so we still have R to the third. And if we do 20 times something, we'll call this X. So 20 times X is equal to negative 160. Then X equals negative 160 divided by 20, so that's negative 8. So R to the third equals negative 8, so R is equal to negative 2. And in that case, if we're multiplying by negative 2, that's negative 40, positive 80. You don't have to fill them all in, but you can just to double check. That would be negative 10, and this would be positive 5. So the first term is 5. The common ratio is negative 2. So the formula is going to be 5 times negative 2 to the n minus 1 power. All right, so for the monitoring progress, we don't really have as much room. So just be aware of that. You don't really need that much room for the first one because they do give you R. So then when you have the first term, R is equal to negative 2. So the 6th term is 96. 1, 2, 3, 4, 5, 6. So that one is 96. Since R is negative 2, they're multiplying by negative 2 to the right, which means they're dividing by negative 2 to the left. So you're going to have 24, negative 12, positive 6 and negative 3. So that's the first term. And so the formula or the rule, a sub n is equal to negative 3 times negative 2 to the n minus 1 power. And again, hopefully you tried these before you're watching this part of the video. For the next part, we don't know what the first term is, and we don't know what r is. So we do know 1, 2, we don't really have that much room over here, or we don't need that much room. There's only 4 terms. So we have a 1, 2, I'm just going to go ahead and write all 4 of them out. This is 12, and this is 3. This means that the numbers are getting smaller, which means we're going to have a fraction. So we have r times r, so that's r squared. And then to get from 12 to 3, to multiply 12 times what gives you 3. If you divide both sides by 12, you get 3 twelfths, which is 1/4. So r squared is equal to 1/4. If you take the square root of that, r is equal to 1/2. But actually, because it's a square root, you need a plus or minus 1/2 on this. So what this means is we don't know if r is positive or negative. It's either. It's plus or minus 1/2. And so what that means is, let's say that, and I'm going to go ahead and do 2 different versions. Let's say that r is equal to positive 1/2. If r is 1/2, then this is 1/2. 12 times a half is 6. So you can see that the numbers are dividing by 2. That's what 1/2 is. So we're multiplying by 2. So if r is positive 1/2, then the formula would be 24 times 1/2 to the n minus 1. Now, let's make r negative 1/2. So if r was negative 1/2, then this would be a negative 6, and that would be a negative 24. So this would be plus or minus on the 1. So if I chose the negative 1/2 for the r, okay, then we have negative 24 is equal to negative 1/2 to the n minus 1. I don't want you to think that just because the 1/2 is negative, that the 24 is negative. That's definitely not necessarily the case. R can be negative 1/2, and the first term could be positive 24. So in this case, they just happen to coincide that the negative ratio is equal to the negative first term, and the positive ratio is equal to a positive first term, but that's not always the same, or not always the case. For the next time, we have a series, and remember a series is when you add everything up. So it's like taking all of these numbers, this is a sequence, and in order to make it a series, you would put a plus sign between all of them. And you can see that if I put a plus sign between all of these, you're going to add 6, then add a negative 12, then add a 24. So the total is going to vary depending on what the ratio is and how many terms you're adding. So the formula is this. Okay, so however many terms you have is equal to the first term, 1 minus r to the nth power over 1 minus r. So for the first one, the first term is 4. R is equal to 3, and n is equal to 10. Okay, also because the denominator is 1 minus r, I'm going to go ahead and write that ahead of time because it'll save you time later. So 1 minus 3 is negative 2. Now, in the formula, S of 10 terms, the sum of the first 10 terms of this series are, the first term is 4. Then we have 1 minus r to the n power divided by 1 minus r. Now, when you put this in your calculator, you can put it in however you'd like, but if you're not sure on your calculator, you would do 1 minus 3 to the 10th first, hit your equal sign, multiply it by 4, divide by negative 2. Your outcome, your total should be 118,096. If you didn't get that, make sure your order of operations are accurate. You have to complete everything at the top first before you divide by 2, and you have to complete everything in the parentheses prior to multiplying by 4. If you put 4 first, then all of this should be in parentheses. I generally like to do the stuff in the parentheses first, make that a total, multiply it by the number in front, by the first term, and then divide. The next one will be a little bit harder because there's a fraction, but go ahead and try it and see if you get the right answers. If you want to do your final answer in decimals, that's completely fine. I would wait to use the decimals until the end, not in the middle. I don't want you to really round in the interim, in the beginning part. Okay, so do not change 5/7 into a decimal. All right, so come back and check. So here we go. So A1 is 6, R is 5/7, N is equal to 12, and 1 minus R is 1 minus 5/7, which is the same thing as 7/7 minus 5/7. So that's 2/7. So if I'm going to add the first 12 terms, we're going to divide by 2/7. Remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So if you don't want to put divided by 2/7, you're more than welcome to just at the end multiply by 7/2. And 7/2 is 3.5. So you can do everything at the top and then multiply your result by 3.5. Now I'm going to just leave it like this because, like I said, you guys have calculators. You should be getting better at using them with the order of operations. So the first term is 6, 1 minus R to the n power. So it's 1 minus, and then you need to make sure that 5/7 is in parentheses to the 12. Okay, so 1 minus parentheses 5 divided by 7, close parentheses to the 12th power equals, multiply that result by 6, divide by 2/7, or multiply by 7/2, which is the same thing as multiplying by 3.5. Your final answer here should be 20.62958, blah, blah, blah. So if we round that to the 10th power, about 20.6. And I'm not going to do example 6, so that does it for 7.3. I'll be posting work on this section.